Hello students, welcome back to maths class. So today we will solve two problems, one 7 marks question and one 2 marks question, right? Sometimes this 7 marks question they may ask for 4 marks question also, right? Little bit a small problem. Okay, so come on, come to this one. First one is 7 marks and second one is 2 marks question. So take the first question. What is the question? So this is 0 to pi x by 1 plus sin x dx. Generally I said 0 to something is there. We will take that value as I, right? I is equal to, what is the value? 0 to pi x by 1 plus sin x dx. You consider this as your first equation, right? So which form it is? Problem is 0 to a f of x dx, right? So whenever it is 0 to a f of x dx, we will take 0 to a f of a minus x into dx. So in a place we are having pi. So I is equal to, what is our I? 0 to pi x by 1 plus sin x dx. This can be taken as 0 to pi. In x place we have to take pi minus x by 1 plus sine of, wherever x is there pi minus x into dx. Pi minus x, 180 minus theta. So this is 0, this is 90, this is 180. 180 minus theta, second quadrant. So in second quadrant, sine is positive, sine and cosec. And for 180 plus theta, 180 minus theta ratio does not changes. Sine remains sine only. So is equal to, it is 0 to pi, pi minus x by 1 plus sine x into dx. This is your second equation. Okay, generally what we will do? We will add 1 plus 2. So I plus I, this side it is 2i. I plus I is equal to 2i. And here we will have same limits. We can write combinedly 0 to pi. First one is x by 1 plus sin x plus next I value is pi minus x by 1 plus sin x into dx. Okay, so if you observe it, we can take the LCM for this. So 2i is equal to, we can take the LCM 0 to pi. What is the LCM here? 1 plus sin x is LCM. 1 plus sin x. Upwards it is x plus pi minus x into dx. Plus x minus x cancels, and whenever constant is there inside the integral, we will take that constant outside, right? So it is 1 by 1 plus sin x into dx. Okay, so 2i is equal to this value. Is there any direct formula for this problem? We don't have any direct formula. So we have to reduce to any standard direct formula. For that sake, we have to multiply and divide with 1 minus sin x. Okay, why we are doing this step here? We don't have any direct formula for that integral 1 by 1 plus sin x. So we have to reduce that into some standard form. To get into standard form, how we can reduce it? Just multiply and divide with 1 minus sin x, 1 minus sin x. Already we did in one problem in the middle, we have taken like this, right? So I think a day before yesterday we did in one problem, same method, right? In the middle of the problem, pi into, come on, 1 minus sin x, right? Here the bounds are 0 to pi, here also 0 to pi. A plus b into a minus b, a square minus b square, 1 minus sin square x into dx is equal to pi into 0 to pi, right, 1 minus sin x divided by 1 minus sin square is nothing but cos square x dx. So now take the values separately. This is 2i only, right? 2i is equal to, we got this one. So pi is equal to, come on, take the values separately. Integral 0 to pi 1 by cos square x dx minus 0 to pi sin x by cos x into 1 by cos x dx, isn't it? Actually sin x by cos square x is there. To get into formula form, we have taken like this. Okay, so is equal to pi into integral 1 by cos square x. 1 by cos square is secant square x dx, right, minus integral 0 to pi, come on, sin by cos is tan x and 1 by cos is secant x dx. See how nicely your problem reduced into standard formula form. We know the formula of integral secant square x, right? It is tan x, and we know the formula of integral secant x tan x, it is secant x, right? So is equal to pi into, this is tan x, right, and 0 to pi minus this one is secant x, integral tan x into secant x or integral secant x into tan x, both are same, is equal to secant x. It is standard formula, right? 0 to pi. What I said, once we have taken the standard formula, we have to write the bounds on right side. So is equal to pi into, come on, in x place we have to substitute upper limit, minus in x place we have to substitute lower limit, minus same with secant also, secant of pi minus secant of 0. So is equal to pi into, we can write tan, pi means 90 plus 90, that means 180. So how we can write 90 plus 90, and tan 0 is 0. Okay, so similarly for secant we can write secant 90 plus 90, secant 180 can be written as, and this secant 0 can be written as 1 by cos 0. Can we write? Secant and cos are reciprocal to each other. So we are finding 2i value at the end, we have to get I value. 2i is equal to pi into, come on, this is 90 plus theta form, second quadrant. In second quadrant, sine and its reciprocal cosec are positive, remaining are negative. Here we are having tan, so it is a negative. And for 90 plus theta, 90 minus theta ratio changes, tan changes to cot. So it is cot 90 minus 0. Okay, so similarly minus, same thing, 90 plus theta, second quadrant, secant is minus, right, and it changes the ratio, secant changes to cosecant 90, right, minus 1 by cos 0 is 1. So is equal to pi into, this is 0, right. So 0 minus 0 minus cosecant 90 is 1 minus 1. Okay, so is equal to pi, 0 minus 0 is 0, no need to write, right. So minus 1 minus 1 minus 2. Okay, so is equal to 2 pi. You got 2i is equal to 2 pi, implies I is equal to pi is the answer of your question. Okay, so observe how we got the values. I is equal to integral 0 to pi x by 1 plus sin x. Generally 0 to a form problem is there. We will do like this. We will consider that as first equation. Then we will apply this most repeated formula. 0 to a f of x dx is equal to integral 0 to a f of a minus x dx form we will apply. Right, that means wherever x is there, there we have to take a minus x. Here in a place we are having pi, so wherever x is there you take pi minus x. Okay, so then here 180 minus theta, 180 minus theta which quadrant? Second quadrant. Sign is positive, and for 180 plus 180 minus ratio does not changes, sign remains sign only. That will be considered as second equation, right? Then you add first and second equations and try to get your I value. Okay, so how we will get that value? If you add x and minus x cancel, pi into root of 1 by 1 plus sin x. There is no direct formula for integral 1 by 1 plus sin x. If it is not there, reduce into standard form. How we can reduce? Multiply and divide with 1 minus sin x by 1 minus sin x. So upwards it is 1 minus sin x. Why? 1 into that value, right? And downwards a plus b into a minus b. So it is 1 minus sin square x is cos square x. Okay, so then you separate it, 1 by cos square x and sin x by cos square x. While writing sin x by cos square x, I have taken sin x by cos x into 1 by cos x, so that sin x by cos x is tan x and 1 by cos x is secant x. So it is standard form. Integral secant x tan x is secant x and integral secant square x is tan x. Okay, so we have to reduce the problem into standard form, then apply the formula. Once we got it, so take the bounds on right side, then in that function wherever x is there, first upper limit minus, in the function wherever x is there, you have to substitute the lower limit. Okay, so that is your 7 marks question. Now come to the second question, that is 2 marks question you can take. Okay, so what is your 2 marks question? Find the integral 1 to 5, right, dx by root of 2x minus 1 dx. That is the given question to you. So come on, you take integral 1 to 5, okay, dx by root of, what is that, 2x minus 1. Okay, so this is your 2 marks problem. Here the value is under root, right? Whenever the value is under root, you take t square is equal to the value which lies inside the root, right? Now differentiating with respect to x, with respect to x on both sides we have to do. So what happens? D by dx of t square is equal to d by dx of 2x minus 1. So is equal to, this is x to the power of n form, n into x to the power of n minus 1. So 2 t to the power of 2 minus 1 is 1 only, right, into dt by dx is equal to 2, isn't it? 2 into d by dx of x is 1 minus d by dx of 1 is 0, right? So 2 cancel. So your value is t dt is equal to dx, sending dx that side. So your dx value is t dt and downward value is root of t square, means square root will get cancelled. That means entire problem now is in terms of t. So we have to change the limits also. Already I said so many times, whether it is 4 marks question, 7 marks question, 2 marks question, if we go for substitution, we have to change the limits. Go for substitution means we are changing the problem in terms of t. So we have to change the limits also in terms of t, right? So upper limit, come on, we have taken here, it is given that upper limit x is equal to 5. So substitute in it, t square is equal to 2 into 5 minus 1, that is 10 minus 1 is equal to 9 is equal to 3 square. So t square is equal to 3 square means what is your t value? T is equal to 3. Okay, now you take lower limit, right? So what is your lower limit? X is equal to 1 implies t square is equal to 2 into 1 minus 1, that is 1. So implies t's value is 1. T square is equal to 1 means we can write 1 as 1 square. So t is equal to 1. So you got your limits as upper limit as 3, lower limit as 1. Now you take your question. What is that? 1 to 5 integral dx by root of 2x minus 1. So is equal to integral. Come on, what is your lower limit is 1, upper limit is 3 and dx, what is your dx? Dx is equal to t dt by root of t square. Okay, so square root cancel, integral 1 to 3 t dt by t. So t also cancel. Integral dt is t, integral dx is x, no? So same thing, integral dt is t. So its limits are 1 to 3. We will write on right side. Now in t place you substitute your upper limit. Again in t place you substitute your lower limit. So it is 3 minus 1, that is 2. That is the answer of your question. Okay, so observe carefully. Very simple. Actually the value is given inside the square root. Whenever value is given inside the square root, you consider that as a t square, so that square root will cancel. So after that you differentiate with respect to x on both sides, right? So then you got 2t dt by dx is equal to d by dx of 2x minus 1, right? Already we did so many times, we used so many times. So d by dx of 2x is 2 minus d by dx of 1 is 0. 2 cancel. So t dt is equal to, sending dx that side, 1 into dx is dx. So your problem is now in terms of t. So limits also must be in terms of t only. So you take upper limit, right? X is equal to 5. Then you will get t square 9. So it can be written as a 3 square. So t is equal to 3. And the lower limit x is equal to 1. If we substitute, we got t square is equal to 1. 1 can be written as 1 square. T is equal to 1. Now once we got lower and upper limits, you take the original problem and substitute. Okay, so finally we got integral dt again in standard form. After taking substitution, at the end you will get one standard formula form, right? So integral dt is integral dx, that is x there, here t. So once we got the value, we have to take the limits on right side. After that, in its place, upper value, upper limit minus lower limit. That is your answer. Okay, so simple problems. If you practice, if you are attentive, here only 80% work will be done. After that, just you practice one time, that is enough. Okay, so that's all for today. Have a nice day.